Hello, I. In the last class is talking about the concepts of Coulomb's law and what is the statement of Coulomb's law, what is the explanation of Coulomb's law, what is the meaning of dielectric media or permittivity, relative permittivity, and one more concept is that is superposition principle by using a Coulomb force. That is today we will discussion about concept of electric field. Electric field, that is the symbol is represented by capital E. Capital E is the electric field. What is the first of all, what is the meaning of electric field? The electric field is defined as, that is the force acting for any positive charge, that is called electric field. The electric field, that is the electric field is defined as the force acting for any positive charge is called electric field. One more statement is, it is a region, the electric field, it is a region in which the electric effect can be observed, that is called electric field. The electric field is defined as the force, that is the force acting for unit positive charge is called electric field. It is represented by symbol is capital E. It is a electric field is a vector quantity. The electric field is a vector quantity. Vector quantity. Then what is the SI unit of electric field? The unit of force is Newton. The unit of force is Newton. The unit of charge is Coulomb. The SI unit of the electric field is Newton per Coulomb. Newton per Coulomb. That is, or one more SI unit is the force. What is the force? The force is equal to mass into acceleration and charge. That is, the unit of mass is kg. The unit of acceleration is meter second inverse square. By unit of charge is Coulomb. That is, the one more SI unit is, that is kg meter second inverse square per Coulomb. That is also same. This is the concept of electric field line. The electric field line is defined as the force acting for unit positive charge is called electric field. The electric field is a vector quantity. What is a vector quantity means what? The vector quantity is a physical quantity. Physical quantity means the any measurable quantity is called physical quantity. That is, the vector is a both. It is a vector symbol. It is a vector symbol. It is consist of magnitude and arrow mark. The arrow mark is that is represented by direction of a physical quantity, direction, and the length of the line. That is linear line can be represented by, that is called magnitude. Both magnitude and direction is present. That is called the vector quantity. That is, the vector is a physical quantity. It is presence of, that is both direction and magnitude. That is called what? That is vector quantity. That is the concept of electric field. And the SI unit of the standard SI unit of the electric field is Newton per Coulomb, or another SI unit is, that is a kg meter second inverse square per Coulomb. This is the expression for, that is the electric field. That is one more concept is, what is the expression? What is the expression for electric field? Electric field due to single point charge. Single point charge. That is, draw the first electric field line. That is the electric field line. That is the expression for electric field due to the single point charge means, first to draw the electric field line. This is called electric field line. The O, that is the O is the point. The positive charge, or that is the Q naught. It is taken as Q naught. The positive positive charge is acting at a point O. E can be represented by electric field line. The distance, and O is the point. That is P. O is the point, and P is also point. The distance between O and P is, it is taken as, that is a small r. That is small r. According to that is the Coulomb's law states that, what is the statement of Coulomb's law? The electrostatic force of attraction or repulsion between the 2 point charges and inversely proportional to square of distance between them. What is the equation? By using a Coulomb's law, according to the Coulomb's law, equation is What is the equation? That is F is equal to 1 by 4 pi epsilon naught, that is 1 by 4 pi epsilon naught q1 q2 by, that is r square. That is the p and q is the two defines. It is a q1 is called, that is a charge q1, that is charge q2. The q1 can be taken as the charge, the transferring of a charge is, it is taken as 1 coulomb, and the q2, that is a q2 is called, it is, that is converted to q only, that is a single point charge. Q is called single point charge. That is by using a Coulomb's law. What is the Coulomb's law equation? That is F is equal to 1 by 4 pi epsilon naught q1 q2 by r square. When assumed that, when assuming or assuming, consider the assuming the charge q1 can be, it is 1 coulomb, the charge q2 can be, that is a q, the distance is r is equal to, can be written as, that is a x, it is called x. X is the distance between two charges. This value, this is called Coulomb's law. The equation is F is equal to 1 by 4 pi epsilon naught, the product of charges and square of distance between them, that is called equation number 1. This is the q1 q2 and r values is substitute equation number 1. The equation number 1 can be written as, that is 1 by the force, the Coulomb force F is equal to 1 by 4 pi epsilon naught. The q1 can be written as, that is a 1 coulomb, and q2 can be written as, that is q, and that is r is replaced to, that is x square, that is according to diagram. Or the F is equal to, the F is equal to 1 by 4 pi epsilon naught q by x square, q by x square. According to, by using a definition of electric field. What is the definition of electric field? The definition of electric field, that is E is equal to force by q, force by q, that is the, it is taken as q1 can be, it is taken as, that is a q or q2. The F is equal to, or cross multiply or F value is substitute in this equation. That is a finally, that is will get, that is a F value, the F value is 1 by 4 pi epsilon naught q by x square, q by x square. Sometimes the charge is taken as the q1 can be taken as, the q1 can be taken as, that is q, the q2 can be taken as, that is q1, that is a q1, or the q1 is as it is, both are same. The q1 is equal to q1 or q2 is equal to q, both are same. Okay, now as this values substitute, this assuming, this values assuming of the q1 is q1, the q2 is, that is average of charge. This values is substitute in above equation, that is the force equation is, that is 1 by 4 pi epsilon naught into, that is the q1 into q by x square, that is the q1 into q, that is the q1 into q divided by x square. Both the q get cancelled, both sides of the q get cancelled, that is the F value. So once again listen, that is A is equal to force acting for unit positive charge. By the definition of electric field, E is equal to force by q. Force, that is the first write the value of force value, that is 1 by 4 pi epsilon naught q by x square into 1 by q, that is q1, that is a q1 can be replaced by q1, again q2 can be replaced by, that is q, that is q1, that is q get cancelled, the numerator and denominator of the charges is both sides get cancelled. Finally the electric field, E is equal to 1 by 4 pi epsilon naught the q1 by x square. This is the expression for the electric field due to the single point charge. Expression for electric field due to the single point charge. That is where, what is the explanation terms? That is the E is a electric field line, the q1 is the single point charge, x is the distance between the 2 point charges, and epsilon naught is the permittivity of the free space. Epsilon naught is the permittivity of the free space. What is the value of epsilon naught? That is 8.854 into 10 power minus 12 farad meter inverse. Farad meter inverse. This is the concept of the electric field due to the single point charge. That is our equation is by using a Coulomb's law. First to draw the electric field line. It is a consist of two charges The small displacement is the distance is taken as x by using a Coulomb's law. The substitutive values of q1, q2, that is q1 can be taken as that is q1 and q2 can be taken as that is q. Substitute these values. The r can be taken as that is x. That is finally that is E is equal to 1 by 4 pi epsilon naught q1 by x square. This is called expression for electric field due to the single point charge. Single point charges. And next one more concept is the electric field lines. The electric field lines. That is electric field lines. How to draw the electric field lines? Electric field lines. Electric field lines. Electric field lines. The electric field lines means these are the imaginary lines, that is called electric field lines, or the smooth curves along which unit positive charges, or the smooth curves along which it is unit positive charges, that is called electric field lines. The electric field lines is these are the imaginary lines. Imaginary lines. How to draw the electric field lines? First one is positive point charge. First one is positive point charge. Positive point charge. That is also called that is the isolated point charge. Both are same. The positive point charge and isolated point charge, it is both are same. How to draw? That is a positive means the direction of the electric field means the direction of the electric fields, it is the diverging. Diverging means the outside of the direction. Diverging means the outside of the direction, and that is represented by the diagram of the isolated point charge is given by first to draw the positive charge and draw the electric field lines. This is electric field lines. The direction is outsides of the charge. Outside. This is the direction is outside of the point. That is called positive point charge or isolated point charge. That means the charge is greater than 0. The charge is positive. The charge is greater than 0. That is called positive point charge. Isolated point charge. The charge is greater than 0. All the electric field lines is diverging the outside of the charge. Next, second one is second diagram is negative point charge. Negative point charge. Negative point charge or that is isolated. That is isolated or the isolated negative charge. Both are same. Isolated point charge. Isolated point charge. And the Q is less than 0. The Q is less than 0. First to draw the charge of the electric field lines at a point negative. Draw the electric field lines. That means the negative means the direction of the electric field lines is converging. Converging means inside of the charge, inside of the point. That is called the direction is inverse. Inward direction. That is not that is diverging. Diverging means outside. Converging. The converging means inside of a direction, that is inside. This is the negative point charge or isolated negative point charge. Next, third one is that is equal two equal positive charges. How to draw the diagram? First, to draw the 2 point positive charges. The 2 point positive charges is that is a one positive charge and one more positive charge. Then draw the electric field lines. This is called electric field lines. This is called electric field lines. The positive means the direction of a electric field lines is diverging, and this is also this is not, that is also diverging and diverging. This diagram is called that is a two equal positive charges. Two equal positive charges. Next, this is the one of the diagram. And the fourth diagram is the two equal negative charges. First to draw this charge of the negative charges and draw the electric field lines. This is called electric field lines. And draw the directions of the charge. The charge is a converging. This is also converging. This is converging. Okay, now This is the converging. That means this diagram is called two equal negative charges. This diagram is called two equal negative charges. This is the one of the electric field lines. Then next fifth one is the equal and opposite charges. That means one is the positive charge, one is the negative charge. First to draw the positive and negative charges. That is the one is positive, another one is negative, and to draw the electric field lines. The electric field lines, positive means diverging, diverging, diverging. The positive means diverging, and this is also diverging, and negative charge, that is also converging, converging inside of the charges, inside direction. That is also inside direction. This is called equal and opposite charges. Equal and opposite charges. This is the diagrams of electric field lines. First one, there are 5 different diagrams of electric field lines. One is positive, positive charge, that is also called isolated point charge, and the second one is the negative charge or isolated negative point charge. The positive charge means the charge is greater than 0. The negative charge means the charge is less than 0. Next, third one is the two equal positive charges. First, to draw the positive charges. The direction of the positive charge is, that is the outward direction. The outward direction means it is a diverging. This is also diverging. Next, the fourth one is two equal negative charges. That is, draw the negative charge and negative charge and draw the electric field lines. The negative means the direction of a electric field lines is, it is a converging. Converging means inward direction. Inward direction. Next, the fifth one is positive and negative charges. How to draw? That is, positive means there is a equal and opposite charges. That is a equal and opposite charges. One draw the positive charge, one more is negative charge. The positive means diverging, the negative means converging. This is the electric field lines. The total 5 diagrams of electric field lines. The electric field lines is a imaginary lines, is called electric field lines. Next, what is the properties of electric field lines? The properties of electric field lines. Electric field lines. That is first property. The first property is the electric field lines is do not form a closed path. The electric field line is passed through the linearly or uniformly. It is not a what? It is a circle or closed loops. That is the one property. There are the electric field lines is do not pass through or do not form a closed loops. Closed loops. That is the one property. The electric field lines is does not form a closed loops. It forms linearly or uniformly. That is the one of the property. And the second property is they do not pass through the conductors. They do not pass through the conductors. Conductors means what? The conductor is a substance. The charges is flows easily. The conductor is a substance. The charges is flows easily. What is the example of conductors? Example: copper wire, silver wire, human body, earth. Alva, current is flow. The current is flows easily in human body and earth also. Copper wire also. Okay na? And these are the examples of conductors. That is, the electric field lines are they do not pass through the conductors. That is the one property. And the third property is they can pass through the. That means the electric field lines is pass through the non-conductors. Pass through the non-conductor. Non-conductor means that is the insulators or dielectrics. Both are same. The electric field lines is pass through the non-conductors. What is the examples of non-conductor? That is the conductors. Non-conductors means that is also called insulators and dielectrics. The examples of insulators is that is a what? One is mica, rubber, and wooden block. That means the insulators means the does not the project. It is also substance. The insulators also substance. The electric charges is that is not easily flow. That is called what? Insulators. Example: wooden, glass, rubber. These are the examples of insulators and dielectrics. That is also one property. That is the third property is the electric field lines is passed through a non-conductors. That is called non-conductors means dielectrics. Next one more property is the isolated positive charge is start from the charge and ends of the negative charge alva. That is the positive charge. See, that is the one property. The electric field lines is, that is a positive, that is a negative. It is start from the positive charge to the end of the negative charge. That is the one of the property. Therefore the negative charges due to isolated positive charge start from the charge and end of infinity ಅಂತ ಹೇಳ್ಬೋದು positive charges. The positive charges means the isolated positive charge they start from a charge and ends of the infinity. The negative charge means the isolated negative charge is it starts from the infinitely and ends of the charge. That is the one property. And the pair of equal and positive charges, that means positive and negative, like and unlike charges. That is the pair of a equal and opposite charges. The electric field lines are start from positive charge to the ends of the negative charge. That is also starts from positive charge to negative end of the negative charge. That is also one property. And the number of electric field lines is passing normally and unit area, it depends on the electric field line. This is also one property. This is called electric field lines. This is called the vertical and horizontal lines is called electric field lines. The number of electric field lines is passing normally through unit area, it depends on the strength of the electric field line. These are the properties of a electric field lines. This is the 3 more or 2 more questions is important. Write the any 2 properties of electric field lines or write the any 3 properties of electric field lines. The electric field lines diagrams also important and properties also important. The first second, once again listen, the electric field lines first property is the electric field line is does not form a closed path. That is it forms a linearly or uniformly. That is a one property. And second property is the electric field lines is do not pass through the conductor. That is a one property. Already told conductors means already definition and examples given to the in the previous classes. And the third property is the electric field lines is pass through the non-conductors. The non-conductor means it is a dielectrics. And the next point is the pair of positive charges and negative charges. The starting of the pair of positive charge, that is the pair of the positive charge is starts, the negative charge is ends of the electric field line. That is also one property. And the number of electric field lines is the next one, the fifth property. The number of electric field lines is passing through the normally the unit area, it depends on the strength of the electric field line. And one more property is that is it intersect to each other. The electric field lines are intersect means it is a joining. That is a that is a one electric field line. This is also one electric field line. That is intersect to the two electric field lines are intersect to each other. That is the electric field lines are intersect to each other. That is the properties of the electric field lines. This is the concept of electric field. The electric field, it is a defined as, one more second, the electric field is defined as that is force acting for unit positive charge is called electric field. It is represented by symbol is E. It is a electric field is a vector quantity. The unit of electric field is Newton per coulomb, or one more SI unit is kg meter second inverse square per coulomb. It is a vector quantity. Then what is the expression for electric field due to the single point charge? It is a consist of only single charge, or single point charge and isolated point charge both are same. That is finally the equation is E is equal to the constant 1 by 4/5 epsilon naught q1 by x square, where q1 is the single point charge, the x is the distance between the positive charges, and epsilon naught is the permittivity of a free space, and E is a electric field line. The E is a electric field line. Next concept is, what is the electric field lines? The electric field line is a imaginary lines. The electric field lines is a imaginary lines. It is called electric field line. How to draw the electric field lines? The first one is a positive point charge. That is, a positive point charge means it is a charge is greater than 0. All the electric field lines is, the direction of the electric field lines is, it is a diverging. Diverging means that is the outside of the diversion, outside of the direction. Next, second diagram is, it is a negative point charge, isolated negative point charge. It is the direction of the electric field lines. All the electric field lines, the direction of the electric field lines is, it is a converging. Converging means that is the inside of the direction. Inside of the direction. That is the one proper. That is the second diagram. Next, what is the two equal positive charges? First, to draw the two equal positive charges. It is a positive charge means it is a diverging. The positive charge means it is also diverging. It is the intersect to each other. The two equal positive charges are intersect to each other. That is also one property. Next, fourth diagram is two equal negative charges. Draw the one negative charge, one more negative charge. That is a negative charge means it is a converging. Converging means it is a inside of the direction. That is a converging. Next, last one is, it is a two equal and opposite charges. That is a equal and opposite means draw the one positive charge, one more is negative charge. The positive means it is a direction is outward. The negative charge means it is a direction is inward. That is the diagrams of electric field lines. Electric field lines. Next, what is the properties of electric field lines? Very important. That is the diagram. See the diagrams. What is the property? Think it. That is the first property. It is not a closed path. It is a linear. Okay, now the electric field lines is does not form a closed path. It is a uniformly. That is the one property. Second property means the electric field lines is do not pass through the conductors. The electric field lines is does not pass through the conductor, and the electric field lines is pass through the non-conductors. The non-conductor means that is the dielectrics. That is the one property. Next, the fourth property is the pair of positive charges is starting to the end of the negative charges, and fifth property is the two electric field lines or intersect to each other. Intersect, that is the joining. That is adjoint. That is the intersect to each other. These are the properties of electric field lines. Next concept is dipole moment. Dipole moment. Dipole moment. Dipole moment. That is, the dipole moment means it is a system. The system is consist of two charges. One is positive charge, one more is negative charge. The distance between the positive and negative charges, that is the 2a. The distance is 2a. That is, the dipole moment can be represented by vector phi. Vector phi is the dipole moment. O is the midpoint. It is represented by vector p is a dipole moment. The dipole moment is defined as, that is, vector p or phi is equal to the product of charge and 2a is the distance. That is called dipole moment. The dipole moment is defined as the product of charge and distance between the two charges. That is called dipole moment. That is, a dipole moment is a vector quantity. Vector quantity. The formula is P is equal to Q 2A. The 2A, where 2A is the chord, that is the distance between the two charges. Q is called, that is charge of a, it is system is consist of charges. It is a dipole moment is, it is a vector quantity. What is the SI unit of dipole moment? The unit of charge is coulomb. The unit of distance is meter. SI system. The unit of charge is coulomb. The unit of distance is meter. This is the concept of dipole moment. The dipole moment is, it is a symbol as P. It is defined as the product of charge and distance is called dipole moment. It is a dipole moment is a vector quantity. The SI unit of the dipole moment is coulomb meter, not centimeter. Not C means coulomb. The unit of charge is coulomb. The unit of distance 2a is the distance. The unit of distance is meter. Okay, thank you.